Okay, so let's see. This one is Chapter 11, Review number 12. In this problem, we've got a center point is 3, negative 2, right here. And the radius is 5, so I'm just going to count 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 over. That's 5, right? 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5 across. And here's my circle, roughly. Not the greatest, but it'll do. And the next question here is write the equation of the circle. Okay, so the equation of the circle, remember, looks like this. X minus h squared plus y minus k squared equals r squared, and h and k is the center point. And so that means I'm going to write x minus h, which is 3 squared, plus y minus negative 2. So y minus negative 2 becomes y plus 2 squared, equals the radius, which is 5, all squared. So you could also write 25 here if you wanted. So then the next part is to find the x-intercepts. So x-intercepts are where it crosses the axis. So let's connect these with radii to the center point. So that's 5 and that's 5 because that's how long the radius is. And we can figure out this length right here. Right? This length right here, going straight up and down, right here, is going to be 2 units long because it goes from negative 2 up to the x-axis. That point on the x-axis, all the y values are 0 there. So this length right here is 2. So then if I wanted to solve for these side lengths right here, I'm going to do 2 squared plus b squared equals 5 squared. Whoa, what just happened? Equals 5 squared. So let's see, that's going to make, why is everything deleting? B squared equals 25 minus 4, so 21. So b is going to be root 21. And I'm at 3, 0 right here, and I'm going root 21 this way and root 21 that way. So I'm going to get 3 plus root 21, comma 0, and 3 minus root 21, comma 0. You can also, since this problem doesn't specify, you could give me decimal answer versions of those answers too. Okay. Okay, so this one's number 13 from the Chapter 11 review packet. And in this one, we've got a circle. I've copied the circle from number 12. We already did some work on it. And you're supposed to find the region inside the circle, but above the x-axis. So if I shade that in with this highlighter, that's going to be this part up on top. Right there. So remember, a good strategy for dealing with that would be if we find the area of that whole sector right there, where this is 5 and this is 5, then what we can do is we can subtract out the triangle. So we're going to do area of the whole sector minus area of the triangle right here, and that'll give me the area of the shaded part. Okay, so we need the area of the sector, and in order to get the area of the sector, you need to know how big these angles are here. So I'm going to call that theta, and it's the same thing on both sides. So to solve for theta, I'll use the 2 and the 5, so that's the adjacent and the hypotenuse. So adjacent and hypotenuse uses cosine. So cosine theta equals 2 over 5. So theta is going to be cos inverse 2 over 5. Which comes out to be, let me type that in and see, cos inverse 2 over 5, 66.4218 degrees. And I need 2 of them, because that's really how big the arc is. It's, since there are 2 angles down here, both theta. So 2 theta is going to be 132.8436 degrees. Okay, so now I've got 2 theta, and I need the entire sector's area. So the area of the sector is going to be my angle, which is 132.8436 over 360 times pi r squared. And in this case, r is 5. So if I type all that in, divided by 360 times pi 5 squared, I get the area of the sector is 28.9819. Actually, that would round up to 20. Okay, so that's the area of my sector. Now I need to get rid of, so that's this part, I need to get rid of the area of the triangle. And if you look at the triangle, the height of the thing is 2, and the base is, whoa, let me undo that. The base is this part right here, which is root 21 plus root 21, so it's 2 root 21. So then that means the area of my triangle is going to be 1/2 base times height, and the base is 2 root 21, and the height is 2. So then if I multiply all that out, I've got 9.1652. So then the last step is going to be area of shaded, or that one region that we were trying to find, is going to be the area of the sector minus area of the triangle. The sector was 28.9820. The triangle is 9.1652. And so then the difference, let's see, minus the other one gives me 19.817. So 19.817 right here is the area of that region. Okay, hope that helps.